everyone, I'm going to go through how to complete the lab for the electrical energy and the specific heat of water. So we're going to use this styrofoam cup. It'll be placed in this glass beaker and then filled with water. This heating coil will go into the cup and the electrical energy supplied to the heating coil will go into heating the water. So the first thing I'm going to do is take the mass of this empty cup. So I'll put that onto my scale and take the mass here and record it on the data sheet. When I have that, I'm going to then put a little bit of water into the cup and just test the circuit. So I'll place this into the glass beaker and the coil in there, and then I just want to check that my voltage and current are set correctly. So ideally I want my voltage to be around 10 volts and the current around 1 amp. Okay, so current and voltage. So that looks about right. What we have is our power supply connected to the coil, back through the ammeter, and then back to the power supply so that the ammeter is in series to measure the current. And we have the voltmeter connected in parallel just to either side of the heating coil. So now that I'm ready to go, I'm going to turn that off for a second and change out this water since we want to start from a zero reference point without any heat added. Okay, so I'll dump that out. Fill that with a bit of cold water. And then I'm going to measure the mass of the cup and the water, and I'll record that. So we'll subtract the mass of the cup from this mass in order to get the mass of just the water. Okay, now I'll set this up here and put the thermometer into the water. This retort stand allows the thermometer to measure the temperature of the water and without touching the heating coil. So I'll wait a couple minutes to allow that to come to thermal equilibrium. And when we're ready, I'll turn on the power supply, start my stopwatch, and measure the initial temperature. Every 1 degree, I'm going to measure the current, the voltage, and the temperature, and record the time. And that will be done in this data table up until we fill out the entire table, so until about 25 degrees. So I think we're ready to go, so I would turn this on and start recording. The voltage and the current will stay mainly constant throughout the lab, even though there is some temperature dependence of the resistivity. Okay, so turning that on, we're ready to go and start, and I'll record the temperature. And every 1 degree, I'll fill in the data table. Okay, so when you have your data table filled in, then we can start to analyze the lab. So what we're going to do is calculate the power for each time. So every column calculate the power, and then we'll calculate an average power by adding them all up and dividing by the total number. With that, we can plot a graph of temperature versus time. If you plot temperature versus time, this small amount of theory here shows that we get the average power equals mc times the slope. So you can use your slope to find an experimental value for the specific heat of water, which is here. And the very last step is to use a percent error to compare to the accepted value for the specific heat of water, 4,186 joules per kilogram degree Celsius. So I hope that helps. Let me know if you have any questions.